Guys, welcome back to my math YouTube channel. In this video, I want to talk about how to solve an oblique triangle. Guys, so far we know how to solve a right triangle, and to solve for a right triangle, we use the basic definitions for the ratios like sine, cosine, or tangent. We know sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. But guys, those ratios or those definitions only work for a right angle triangle. But if we have an oblique triangle, which is something different than a right angle triangle, we should also be able to figure out the missing values for the angles or the sides, which means solving for any type of a triangle. Guys, those definitions for sine, cosine, and tangent only work for right triangles. They are not going to work for any other triangle except for the right triangle. So we have to figure out new rules or new ways to figure out or to find the missing sides or missing angles in any given triangle. So there's two rules that help us to find the missing sides or missing angles. Guys, one of the rules is called the sine law and the other one is called the cosine law. Yes, there can be a tangent law as well, but guys, we know tangent is nothing but the ratio of the sine over cosine. So if we know the sine and cosine, it is not too complicated or too difficult to figure out the tangent. So we don't really have to talk about the tangent rule as a separate rule. All we need is the sine and a cosine rule to figure out the missing sides or missing angles in any given triangle. Yes, if the sine law and the cosine law works for oblique triangles or any type of a triangles, it will also work for a right triangle. So guys, once you understand and you learn the sine law and the cosine law that I'm going to talk about in this video and in my coming video, then guys, it's up to you whether you still want to use the basic definition for the sine, cosine, and tangent, or you just want to use the sine law or the cosine law. It depends on the problem, it depends on your convenience and what you want to do, which rule you prefer more. Okay, so guys, let us start actually deriving or finding this sine law. We'll start with the sine law and then we'll talk about the cosine law. Guys, it is not too complicated to actually derive the formula or derive the sine rule, so I'm going to actually try to do that in this video. So to do that, first of all, I'm going to start by drawing a triangle, an oblique triangle, and for that particular triangle we are going to figure out the sine rule. Okay, so let us say I have a triangle and let us call it's an oblique triangle. Let us call this as triangle ABC. This is ABC. And guys, the side opposite to this vertex is going to be my small letter A, and this is going to be my B. This side, the length of this side is B, and then this is going to be my C, right? And then this is my angle A, angle B, and angle C. So we want to figure out a rule that can help us to solve for this particular triangle. So one of the things that we can do here is, again, we cannot use this definition SOHCAHTOA. We cannot use that definition because it is not a right triangle. If it was a right triangle, then we would have used that and we could solve for this right triangle. But this is not a right triangle. This is an oblique triangle. It's different than a right triangle. So one of the things that we can do here is we can drop a perpendicular from here onto this line AC. So let us drop that perpendicular. This is 90 degrees. Guys, let us call this height H. So based on this, we can write few equations. So guys, now let us look at this right triangle and let me call this D. So let us talk about this right triangle ADB. We know this is also 90 degrees. Guys, in that right triangle, can we say that the sine of A is, we know it's a right triangle, so we can use the basic rules for the sine ratio, which is sine is the opposite over hypotenuse. Can I say sine of A is H over C? Okay, we can say that for this right triangle. Similarly, okay, from here, guys, let us cross multiply. We know there's an invisible one here. If we cross multiply, we get H equals to C times sine of A. I'm going to preserve this. Guys, then let us look at the other right triangle, because when we drop this perpendicular, we were able to divide this oblique triangle into two right triangles. So let us look at this other right triangle BDC. Guys, in this right triangle, what is sine of C? We can use the basic definition for the sine ratio. Sine is the opposite over hypotenuse. So sine is going to be H over A, because we are looking at this right triangle. From here, again, let us solve for H. Again, we'll cross multiply and we'll have H equals to A times sine of C. Guys, if you look at this equation and this equation, since both are equal to H, So from these two, it implies if the left hand sides are the same, then the right hand sides also have to be the same, right? So from here, we can say that the C sine A equals to A sine C. I want to make sure that we can see the difference between the angle. Angles are usually written with capital or uppercase letters, and the sides are usually written with the lower cases, okay? So guys, let us look at this guy right here. From here, what I'm going to do is we are going to divide both sides by sine A and sine C, okay? We're doing all this to get a nice rule which we call as the sine rule. So and that's why we started by using the sine and not the cosine, okay? Here same thing, if we divide the left hand side by that, we got to divide the right hand side by the same thing, sine A sine C. Guys, if we divide by this, what's going to happen? This is going to cross out, we'll get C over sine C. And on the right hand side, sine C and sine C will cross out, we'll have A, side length A over sine of angle A. Guys, this is part of the sine law. Well, there's one more thing. So guys, this is what we get when we drop a perpendicular from B onto AC, and then we have two right triangles, and we write the sine for angle A, angle C, and then from that we get this ratio, which is equal to each other. Guys, we can do the same thing like we did here. From B we dropped a perpendicular to D. From A now we can drop a perpendicular onto the opposite side. Similarly, we can drop a perpendicular from C onto this side. So if we do all that, and I'm not going to do all that extra work here, but basically that's the idea. We're going to basically follow the same procedure and same steps. Eventually, guys, what is going to happen at the end when we drop these perpendiculars and we go through these steps, it's basically just repeating the same two steps, but the angles will be different. It would be angle B and C, and then it would be angle, for one of them it would be B and C, then it would be A and B. So at the end of the day, guys, this is what we are going to get. We are going to get a nice equation which is going to look like this. We're going to get an equation A over sine A is equal to B over sine B. Keep in mind, these are the lower cases. Lower cases are the lengths of the sides, and upper cases are the angles, right? And this is equal to C over sine C. Well, A over sine A was equal to C over sine C. We were able to justify that from this work. Guys, this piece comes in when we use the other two steps of dropping perpendiculars from the other two vertices, okay? So finally, this is what we get, and this is called the sine law. Guys, it is not a complicated law, but we just have to draw perpendiculars to actually get it. This is not the only way people like to see it or use it, guys. There's another way of writing it, and I sometimes like the other way as well. So I'm going to write the other way. The other way of expressing the sine law, the same thing, and you would understand it's not too complicated. Guys, instead of writing A over sine A, sometimes you will find this in the textbooks as well. People like to write sine A over A equals to sine B over B equals to sine C over C. That is also called sometimes the sine law, which is totally fine. Why? Because we know if we work with if we have 3 over 2 equals to 6 over 4, right? Then if I reciprocate these, 2 over 3, this is reciprocated like we did here. This is going to be also reciprocated, 4 over 6. They are still going to be equal to each other. So, guys, either you like to use it in this form, or you like to do it in the other form. It's up to you. We'll try to use these in this form or the other form when we actually work on actual examples. And guys, actual examples are going to be triangles, and we will have to solve for either the angles or the missing sides. Okay, guys, this is the sine law. It is not even too complicated to remember. It just simply says that you have to take the ratio of the side and divide by the sine of the opposite angle. Side divided by the sine of the opposite angle. That ratio is going to be equal to the length of the other side, B over the sine of the opposite angle. Same thing is going to equal to the length of the third side divided by sine of the opposite angle. So when I have to use the sine law initially, like if I'm just starting to use it, I like to first draw for myself, for my reference, as triangle ABC, and then I write the sine law and then I apply it to a particular example. Or the other thing is to kind of remember the conceptual way of understanding this thing is that you have to remember that sine law tells me that the ratios of the side lengths over the sine of the angles opposite to them are equal to each other. That's what we see from here. From here, it's just the ratio of the sine of the angle over the side opposite to them. They're going to be equal. Okay. So it's up to you which way you want to use it. Guys, this is the sine law. Similarly, we have another law which is called the cosine law. Because guys, there is going to be a situation, there's going to be a case where, actually there's two types where sine law may not work, which means we may not be able to find the missing lengths for the sides or angles using the sine law. So for that, we need another law which is called the cosine law. Guys, first I'm going to do examples on the sine law in my next videos, and once we do all the different types of examples in the sine law, and then we are going to go into the cosine law. So guys, take some notes on this. I will see you in the next video with some